View was ideally on similar and congruent triangles. Your SQL quiz today will be over this. Mainly, could have a little bit of transformations on it. Which questions do we have? 23. Okay, so we've got Noah and Ben after swimming in different directions. Use the distance from Noah to Ben, which represents all the possible values in yards and feet. Okay, so we're looking for our third side here. In order to find our third side, we want to add and subtract what we've been given. So if I add these together, that would give me 7, 14. And if I subtract them, 4 minus 3 is 1, 8 minus 6 is 1. So our third side has to be between 21 and 147. Now for this problem, that was all the information they gave us, so we know our answer is going to be this. But sometimes for these types of problems, they like to add in another piece of information. For example, let's say that they said this was 100 degrees, and let's say that this was, what's that look like, 30? So sometimes they'll give you another piece of information that allows you to tighten down your restrictions even more. Okay, so you always need to be mindful of all information that they give you. If they were to also give me this, what would that tell me about my length D? It's the largest, good. Okay, and then we would know, let's see, this would be our smallest, this would be our medium. Technically, we didn't even have to know this angle to figure that out. We at least knew if this is 100, we can't have another angle larger than that. So if they were to give us this, then we could tighten down the restrictions even more. So it could be up to 147 because it is the largest, but it couldn't be smaller than 84, right? It'd have to be bigger than 84, and it'd have to be bigger than 63. So we could technically, if they gave us more information, we could tighten this restriction down even more and say, well, it's got to be bigger than my medium, so it'd actually be 84. 147. Okay, so sometimes they give you more information that requires you to tighten down the restriction. It's not always that you tighten the lower, sometimes you tighten the upper, it depends on the information they give you. So for this one, they didn't tell us that, so our answer is just C. But keep in mind, sometimes they do give additional information that tightens the restriction more. I'm glad you asked about that. That's our questions, right? Okay. Does this look like 20? Okay. Alright, so which figure contains a pair of similar triangles? So our similar triangles, we have angle similarities, side similarity, and side angle side. Alright, so AB intersects CD. Okay, it didn't tell us that it intersected equally, so I would know at least my vertical angles are congruent. So I would say this one by angle similarity. It just says triangle ABC. They didn't tell us that this was isosceles. They didn't tell us that this was perpendicular. So we don't have any more information on that. We don't know that it's been cut in half equally. Given that it's a quadrilateral, you don't know parallelogram, so be careful there. They're trying to trick you with parallelogram. Just know it's quadrilateral, so I don't have opposite angles are congruent. Here, this side is congruent. And then here, they simply tell us that A, B, and C are collinear. These are not vertical angles, so we don't know anything's parallel. There's nothing more we can do. So this would be the only one that has enough. Other questions on our SQL? Awesome. Okay, let's take a look at our main madness. So you had to write out how to prove congruent, how to prove similar. So we have side, angle, and HL are our congruent ones. CP, CTC is corresponding parts that congruent triangles are congruent. And then ways to prove similar triangles, so make sure you have that little squiggle afterward for similar. Side, angle, side. Now for similar triangles, it's not that my sides are congruent. What's true about my sides? For similar triangles. They're proportional, good. What does it mean to be proportional? Same ratio, same scale factor. Good. So we're checking that, whereas for our congruencies, we actually need those pieces to be congruent. Right? And if they form a triangle, check that your small and medium is bigger than the large. That's our shortcut. The long way is check that any 2 is bigger than the third. This is our shortcut way. How do you determine the small angle given the length of the side? So the small angle is across from the small side. Likewise for your medium and large. And how do you find the range of the third side? That's the one that we started off with. Add them together and subtract them. Again, if they give you more information about the angles, then you can determine small, medium, large side. We have questions on our main maths. This one here? So if we know, so how do you determine the small angle if they give you the sides? So my small angle is across my small side. My medium angle is across my medium side. My large angle is across my large side. So let's say that I had this was 80. Say that this was 40, and this would be, okay, we're talking about angles, right? Pretend that I did not say this. Wait. Okay. So they gave us sides. So let's say that they said this was 10, this was 15, and this is 3. So my small side is going to be across my small angle. So this is my small side, this would be my small angle. This is my medium side, this is my medium angle, large side is large angle. And then the opposite is also true. They give us certain angles, we can do ourselves. Other questions on our main matrix? Okay. Ooh, we need to take a look at our transformations review. Let me bring up that homework. Oh, you didn't have to do the back yet for homework. I'm going to go ahead and outline these in a darker color for you, just so you can get the general idea of what it should look like. So remember, when we're doing our reflections, you want them to be the same distance away from the line as they were before. So if they were 4 to the left, you want to go 4 to the right. I feel like this one looks like a fish skeleton. This one did go off. Just remember with the reflection, again, count the same distance away. The trickiest that it gets is when we do y equal to x, y equal to negative x. Kind of count diagonals, or you can just flip-flop your points. I'm going across like y equal to x, the point x, y, which transforms to the point y, x. So they just flip-flop locations. Same thing with y equal to negative x, it's just they flip and change things. Do we have questions with their reflections? Like the y equal to x?
Yeah, like how when you're trying to when you ask negative 1 or y is how do you tell?
So let me go to okay, so let's take a look at like let's go y equal to negative 2 this time here. So I want to first draw in my line y equal to negative 2, so let's do that horizontal line here. So then what I'm doing is I'm just counting the distance the points away. This is on the line, so it doesn't reflect it. This one is 1 above, so I want to go 1 below. And then guys, connect as you go so you can kind of see your shape forming. This is 1, 2, 3, 4 above, so I'm going to go 1, 2, 3, 4 below. And this is 1 above, so I can go 1 below. Now, when we go with the diagonal ones, they're kind of weird, because those are nice vertical and horizontal distances, right? When we have like this guy where it says about the line y equal to x, again, you can draw in that to kind of count from there. So like this, I would see it's 1, 2 diagonals away, so I want to go 1, 2 diagonals below. And then this is 1, 2, 3 away, so 1, 2, 3 here, and then just kind of connect as you go. Or you can take these points and then just flip-flop them. So like this point here is 1, 2, 3, 4, 0, negative 1, 0. So then your new point, you just switch them because we have the line y equal to x. So what was our y is now our x, what was our x is now our y. So now we just switch and we have 0, negative 4. So if you go 0, negative 4, 1, 2, 3, 4, here it is. But again, if you just count, it's 1, 2 diagonals away, so 1, 2 diagonals away. Other questions with that part of it?
The first one, this one.
About the x-axis? Yeah. So our x-axis is this guy here. Really high. So my original is this guy. Alright, so this point here is 2 above, so I want to go 2 below. This one here is 1 above, so I go 1 below, and it's directly below it. And then connect things. And this guy is 1, 2 below, so I'm going to go 2 above. Does that make sense? And let's go ahead. So then our ones down here. So these are our shiftings. We go up and these guys for you. And so remember, this is just a different style of notation. Our first one where it says 1, 2, that's the same thing as saying x, y. If we were to use the other notation, maps onto x plus 1, y plus 2. Or in other words, shift right 1, up 2. This is just the vector notation for it. And our S going a little bit off. And then here was a combination. Make sure you do it in this order that they ask you to. You can see that on mine I've made little X's for my kind of intermediate, and then I first shifted it and then I took those and reflected it. You don't have to draw those if you don't want to. It would just help me out. Okay, and then down here, these figures were not very nicely drawn, so not the best problems. So here, if this were a rectangle, because they didn't give us indication that it was a square, then we only have the 2 lines. But suppose that it is a square, we would have 4 lines. Okay, on your assessment, it will be clear. It would either give markings to indicate that it is a square, or it would say it's a square, or it is a regular quadrilateral. Here we just have the 1. Here we've got our diagonals and our vertical and horizontal. And this one, I find it debatable because it looks like that this is not the same length. So if you said, hey, it's not the same length, there are none, good work. But if you thought it was the same length and then so there's 1, that's understandable as well. So that, I'm going to call that a diagonal.
Wait, what did you the first one?
So they didn't give us indication that it was a square, so technically we have to make the assumption it's a rectangle. There's just 2. But if it were a square, then we would have 1, 2, 3, 4. So remember, lines of symmetry is just what folds in half. Yes?
Will those rectangles come like the diagonals?
Let me go extreme for you, that make it a little easier. If I were to cut it down like this, notice when you fold this down, then you would have this like this. You see that? So basically, if you were to take any 8.5 by 11 paper, this is a rectangle, got to fold it along the diagonal. See how it doesn't map onto it perfectly? You're correct, you have 2 congruent triangles, but doesn't fold onto itself in half. Whereas this would be a line of symmetry because it folds onto itself evenly. Does that make sense, the difference there? Other questions with that? Okay. So our agenda for today, with our remaining time, we're going to take a look at our little bit of constructions review, just to make sure we're all okay with that. We have our SOL quiz numero dos, and then any remaining time, you can just go and work on your review packet for our Quest next class. So our Quest next class is on constructions and transformations. Okay, so your review packet practices the transformations. What you have in front of you is that constructions review. I want to give you time in class where you have the compass in hand to practice that. The key for this is up on Blackboard. Also up on Blackboard is like an in-class key for our construction, so you can see the markings for that as well. Your quest is limited just to transformations and construction. Okay, that's all that's on your quest.
Quest is fast grade.
I think it is somewhere around a 50-point test grade, if I recall correctly. The points might be a little bit different because I'm adjusting it. Okay, so I want to go and take a look at our constructions review. You had a good chunk of time to just go ahead and practice that, and so I want to take a look at that and go over any that you're unsure of the instructions for. Specifically, I want to first take a look at our copying an angle, because this is one that every year, even though I give extreme caution to you, some of you guys forget by the time the quest comes about how to do it. So if you would turn to our copying an angle, I think it's on the front of the second page.
Quiz test.
Quiz test, quest. Good work. Okay, so when we are copying an angle, you will almost always have that your angle is labeled with our rays here. You are not using those points for your construction. If you happen to go through those points as part of your construction, that's fine. But we are not using those points specifically for my construction. They are only there to label. Okay?
Wait, do we label everything?
You will label. It's just what I have students do is they put their compass on A and C and don't actually draw the first arc. So our steps for copying an angle is that, first of all, you need to have a segment to start off with. But once you've drawn that, then we go ahead and we need to know how much our angle opens up. So the way that we go about that is we first take our compass, set it on B, and then draw an arc that intersects both rays. Now again, if yours happens to go through A or C, that's fine. But don't try to make it happen that way. I just copy my arc over here. And so now what this does is it tells me where to measure the width. So now I go to those intersections and I change my compass to match up with that width. I'm basically using my compass kind of like a ruler. And then I go over here from the intersection, I make that little mark in there. And that is what I connect together for my angle. So then when we label this would be A prime, B prime, and C prime. Notice I did not set my compass on A and C for this construction. The mistake that I have students make every year is they don't do this and they just measure the width between A and C and then pop that over there. But you don't know that A and C are the same distance away. And it might look like they are and it'll be close, but I will intentionally draw it so that it is not the same. And when I grade your constructions, I literally take a compass and go to every single person's construction and match up the arcs to make sure you guys have done it correctly. So make sure you are drawing in your markings. Don't erase it. You can clean it up if you want. Don't erase your markings. But that way I'm able to see, did you just go from A and C or did you actually go through the process of drawing your arc so that it is actually the same distance away from your vertex, and then use that for your little marking there. Okay, so same thing for bisecting the angle. We don't use our ray labelings for that. I don't use D and E. If you happen to go through it, great, but we don't actually use those. Our bisecting the angle is a similar process. We first draw an arc that intersects on both sides. And then from those intersections, not from D and E, from those intersections, we go ahead and draw intersecting arcs. Now this might happen above, it might happen below, it doesn't matter, just wherever it intersects. And then that is what I'm connecting together. So again, when I'm grading your constructions, I'm looking for that arc intersecting and then the intersection of the arcs there. Notice I did not use D and E. Okay, those are just there for the. All right. So taking a look at our constructions, are there any that we need to see that you would like me to go through the example of if you weren't sure how to do it? Andrew?
Perpendicular through a point. Off
Yeah.
the line.
All right, so perpendicular through a point on the line, off the line. So let's take a look at, I'm going to go with this guy here. So perpendicular through a point off the line. Sometimes you have to extend out your line for that. I'm going to go ahead and do that actually. And you just use your ruler for that. I'm going to take my compass. And it actually ends up being the same instructions regardless of whether the point is on or off. Your first thing that you do is put your compass on the point, and you want to draw so that it intersects the line on both sides or in two spots. So if you were on the line, then it would just be on the left and on the right. If you're off of it, then it's just going to be below it. Now from those intersections, we go ahead and draw intersecting arcs. So from those intersections, draw our intersecting arcs, and then that's what we connect today.
When you do it on the line, you should do both, like, on top of it and below it.
You technically only need one because you can use the point X as your other point, but it's fine to do it both above and below. And if you're on the line itself, when you once you have your markings, so I'm going to go ahead, I know it's not going to stay on it, but once you have your markings on either side, so I would need to extend out my line here. You, for this one, will have to actually make your compass bigger, otherwise it won't intersect. So you have to actually make it bigger, and then you can do your either above or below, or both from either one. Other ones, just.
Do you have to do the full, like, kind of semicircle kind of thing?
No, you can just have the marks there. Yeah. Yeah, you don't need to have what's in between. So,
Construct the midpoint.
yeah. So for constructing our midpoint, technically we're going to do a perpendicular bisector, even though it's only asking for the midpoint. So perpendicular bisector cuts it in half and is perpendicular, and that will give us our midpoint. So if they want perpendicular bisector, if they want midpoint, or if they want bisecting the line, it's all going to be the same construction. So we take our compass. And we want it to be more than half the distance. And what we're basically doing is just drawing a little arc above and below. So here's arc above and below. I guess that's technically below and then above. And then we just repeat on the other endpoint. I've lost my compass, so I'm going to go ahead and draw. Ideally, you don't want to draw that whole arc. And then we just connect those two together.
Is that the same thing you do for perpendicular bisector?
Yep. So it's going to be the same for perpendicular bisector, bisecting the segment, and midpoint. And then just make sure, guys, you don't forget to draw in your markings to indicate that this is the midpoint. If it's asking for perpendicular bisector, we'd also add others of these that you need to see. Okay, and then I just want to refresh your memory of the ones that we did 2 stingers ago. So as our hexagon or equilateral triangle inscribed inside, that's the new thing the SWAL has added this year. So I just want to refresh your memory with that. This is where they give us a circle. I'm going to go and draw a center here. So they give us a center and they say, all right, I want you to inscribe a hexagon or inscribe a triangle. Who can remember? Does anyone remember what we do? Let's go with hexagon. Dylan.
With 6 different points around the circle.
Good. And what's the width that we're using for that?
The radius.
Good. So we take our compass and set it to the radius. And then we simply use our compass once we've got that. And we mark that distance across. And then just repeat over and over and over again. And it happens 6 times. So then once we have those 6, How do we do the hexagon? What do we do? You just connect them. What if they ask for the equilateral triangle? Yeah, you just connect 3 of them. Which 3 do we do? I heard some mumblings for that one.
So look,
Every other, good. So hexagon, you connect all 6. For triangle, you do every other. So hexagon, triangle would be nothing too crazy there. Okay, come on, Smart. It's fine. Right, it's gonna be a little off. Smartboard rejects me. Okay, and then hexagon, we can connect all of them. Okay. For the square, I feel like they like the hexagon equilateral triangle more, but suppose they ask for this square. It's going to be a different process, but we basically use what we know about perpendicular bisector for this. So let me go and draw my circle real quick. Okay, so what they have us do is first draw they tell us to put a point on the line, and then draw in your diameter using that. And our diameter has to go through the center. And then we basically just do the perpendicular bisector of this. And just to refresh over perpendicular bisector, that's what we're just doing. Now, technically, we already have the center there, so we don't have to do an arc above and below. We could just do it on one side, because we already have our radius, our center marked in. All right, so I'm going to go up. And let's go below. And then just repeat on the other side. Above. And I want below. Alright, I count this one too far. Now mine just happened to connect pretty close to the circle. It doesn't have to. Ideally it would connect inside or outside. And then I just connect those intersection points. And then that, where it crosses your circle, that's what we use for our square. So if I were to actually make my square, I'm going to do it in orange here. Because we know for a square, our diagonals are perpendicular, and they're bisecting. We did a perpendicular bisector. Okay. So just refresh your back. Any questions with that? Yes? No. It's fine if you do. It just looks a little messier. Yeah. So the smaller your markings, the nicer your end result is, but I won't take off points if we go ugly. Okay. All right. I want to go ahead and hand to you your review. We're going to take our SOL quiz next, but that way you have this to work on once you're done with your SOL quiz. While I'm passing this out, do you guys mind to go ahead and return the compasses, unless you want to hold on to it to practice after your SOL quiz? But if you're done practicing, go ahead and return compasses and rulers. Alright, so again, your homework for tonight, you've got your review packet, the answer key is up on Blackboard, and then you still have a little bit of main madness, a little bit of SOL review. So just look at your assignment sheet for that. Alright, and then we'll transition to our SL quiz. Once you're done with your SL quiz and you turn it in, you can go ahead and work on your homework, whether you want to practice constructions review or just work on the transformations review. Remember, the answer key for that is up on Blackboard.